here we're going to just look at finding the sample correlation coefficient. So I have a previous video that actually finds the coefficients of the linear regression line. So these problems, depending on which one you get, are going to ask you to find the y-intercept, the slope, or the correlation coefficient. So I've already done the y-intercept and the slope on a previous video. So we'll look at if you need to find those. This one is just talking about the sample correlation coefficient, which is our R value. So here, managers of an outdoor coffee stand in Coast City are examining the relationship between hot coffee sales and daily temperatures, hoping to be able to predict a day's total coffee sales from the maximum temperature that day. The bivariate data values for the coffee sales, denoted by Y in dollars and the maximum temperature in X, for each of the 16 randomly selected days during the past year given below. These data are plotted in the scatter plot in figure 1. Also given the products of the temperature values and coffee sale values for each of the 16 days. Okay, so we have the temperature, X is our temperature, and Y is our coffee sale. So we're trying to see if it gets hotter, do we start selling less coffee, basically, is kind of what we're thinking here. So we have a graph that's negative, so that is actually what that means. When you have a positive graph, it means as X increases, Y is also increasing. I'll write that over here so you can see it. So positive means as X increases, Y increases. Negative means, not the exact opposite, it actually means as X increases, Y is going to decrease. So that's kind of what we're looking at here. Since we have a negative graph, we're saying as the temperature is increasing, it looks like our coffee sales are decreasing. So this is a negative graph. So that's one thing to tell. You can make sure you get it right here. So since we have a negative graph, and it's negative because from left to right it's going down, since you have a negative graph, your R should be negative and your slope should be negative. So that's one way to kind of check our answer here. So before we go find R, just to say something quick about it. So R is always a decimal number between -1 and 1. Okay. So R is always between -1 and 1. The way it works though is as R goes towards -1, as it goes towards -1, it gets stronger. As it goes towards 0, it gets weaker. And then as it goes back towards 1, it gets stronger. So as you go towards -1, it gets stronger, or as you go towards 1, it gets stronger, but if you go towards 0, it gets weaker. So it's kind of, I mean, if you think about like percentages here, like if it's a 20% correlation, that's kind of a weak one because it's closer to 0, which is 0.2. If you have a 90% correlation, which is 0.9, it's a very strong correlation. Same thing on this side, but you could use negative numbers. Like negative 20% would be a very weak negative correlation, whereas like negative 90% would be a very strong negative correlation. So all the positive and negative tell you is the direction or whether they're increasing or decreasing. But as you go towards 1, it gets stronger, or as you go towards -1, it gets stronger, and then as you go towards 0, it actually gets weaker. All right, so that is a little background on R, which is the sample correlation coefficient. So now let's go actually do this. So I've got this formula up already for you. I just found it by clicking on sample of formulas right here, or the list of formulas. So we are using this one down here. So this one has this crazy looking one right here. I'm not doing that. That's the long one. We're going to do the shortcut one, which is right here. So the first thing they have here is the sum of X and Y. So I'm going to kind of write them out so we can have them when we do this. So this is, you do X times Y, you do each X times Y, and then we're going to add them all up. Well, if I look right here, they already have it for us because 38.7 times 19.98.3 is equal to this. So they did each row for us. So if they did not give you this column, what you have to do is take this one times each other, these two times each other, these two times each other, these two times each other, and then add them all up. On the other video, I did give you a hint of how to do that quicker in Excel, but they give us a column for us, so that is nice of them. All right, so sum of X, Y. So what we're going to do is we are going to highlight this column so we can get all these numbers in the calculator. And then all we got to do is hit the sum of X button right here because that's going to sum whatever we have in the calculator. So now I have that number, 173.72.69. All right, the next thing is on this formula is the N. The N is how many total days we kept track of. So what is it? 16. And we look back at the problem, or we can count how many rows there are. There's 16 rows, but it says right here in the problem 16. All right, so the next thing we have to find is the X bar. The X bar is the average of the X's. What's nice here is our calculator does that for us. We have an X bar. So all we have to do is go highlight everything in the X column, and we hit X bar, and it's going to find the average for us. Same thing with y bar. That's just the average of the y numbers. So let's clear this. Make sure you clear that. I'm just going to go highlight all the numbers in the y column and then hit the x bar. It's okay that it's an x and not a y. That means you're finding the average. So find the average of the y's, 1875.125. So that's everything we need in the numerator. Okay. So now to the denominator, the first thing is the n minus 1. N is the total number of days. So 16 minus 1 would be 15. The next thing you see is the S of x. The S of x is the standard deviation of your x's, is what that's saying. So again, we have it. It finds a standard deviation for us. All we got to do is hit that button. So I'm going to clear everything out of the calculator, highlight my x column, and just hit that S. So there's my standard deviation of the x's. So remember, the standard deviation is how far the data is from the mean on average. Okay, so if we looked at this, like one simple marker for this could be, if I did 59 plus 14 and 59 minus 14, that would be 45 to 73. So 45 to 73. That means the majority of these days are going to be somewhere between 45 to 73. So that's kind of a simple marker. So standard deviation is how far the data is from the mean. So now let's find the standard deviation of the y's. Again, clear your calculator because you don't want that number to actually get mixed in there. Copy my y's. I just highlight them and they go in here. Now we're going to find the standard deviation of my y's by pressing that. So I get 236.5205685.2. All right, so that's everything I need to do the formula. So now clear the calculator. Let's go put this in. So the first thing is the sum of x and y. So 173.72.69 minus n times x bar times y bar. I'm going to go ahead and press enter because that's everything in the numerator. Now I'm going to divide it by n minus 1, which is 15, times s of x, the standard deviation of the x's, times s of y, the standard deviation of the y's. Press enter, and we get our number. So this is negative 0.63, we'll say at least 3. So if I put 4, I'm going to change that to 2. Okay, so negative 0.632. So this is what they call a moderately strong negative correlation. It's moderately strong because it's kind of right in the middle between 0 and negative 1. Okay, so this is almost a very strong negative correlation, but we know we got a good chance we got it right since we have a negative. Our graph is negative. Those dots are pretty close together. That's another way you can kind of tell is if you've looked at the linear regression line, if you drew a line like right in the middle of these points, the linear regression line is how far away these points are to the line on average. The line's kind of like the average of the points. So the closer those points are in a line, the stronger our correlation is going to be. So these are pretty strong. It's a moderately strong negative correlation because they're pretty close. We can easily tell it's going in a negative pattern. That should be our answer. Let's check it. And we are done.